Hello friends, we have studied dimensional tolerances and why those are required. Similarly, we have seen why geometrical tolerances are required. Now, we are going for geometrical tolerances. It is refinement to dimensional tolerances and controls geometrical features. We will see how it is used to define the allowable variation in form and size of individual features, or to define allowable variation between features. Geometrical tolerances are classified in two categories: independent geometrical tolerances and dependent geometrical tolerances. Now consider a square bar. When we say about straightness of bar is not depend on any other geometrical feature of the job. There is only itself. Straightness as geometrical feature is being controlled. Suppose we are talking about top surface of this square bar. Similarly, circularity, cylindricity, flatness are also independent geometrical tolerances. Now consider the same square bar and same top surface, and when we say about parallelism, one straight feature of the bar must be parallel to other, and therefore there we need the reference of other straight feature. Like this, here for being parallel, the top surface needs another surface which will be equidistant to it, means parallel to it. Means controlling of required feature depend on other features. Now we will see one of the independent geometrical tolerance, that is straightness. Straightness is the condition of surface or axis where all elements of it are in a straight line within specified tolerance zone. Suppose we have to control straightness feature of top surface of this job, then we will have to mention it using feature control frame, where in this feature control frame, in first block, straight line is indicating the feature symbol. This feature symbol is for straightness, and this 0.02 is the straightness tolerance zone. So this straightness tolerance zone is defined by two parallel lines which are 0.02 distance apart from each other. Now this top surface which we have to control for straightness may lie like this or like this, but in both the condition it is within the specified tolerance zone in between these two parallel lines, so it is acceptable. Now let's consider another example. In this time we are applying straightness condition for axis of the shaft. So it is saying that this axis should be straight within this specified tolerance zone. So for this purpose, again, it will be defined by two parallel lines which are 0.02 distance apart from each other. So once again, it may be like this, but as it is in between these two parallel lines, so it is acceptable. Or it may be like this, or you can say, let's see here separately, in between these two parallel lines which are 0.002 distance apart, this axis may lie like this, or say like this. In all these cases, it is in between these two parallel lines, means in the specified tolerance zone, so it is acceptable. Now we will see how geometric tolerance is defined into dimensional tolerance. Suppose this is a job, 12 is width and this is height, 10 plus minus 0.05. This is the dimensional tolerance. And we have to control upper surface for straightness. So in this first block, this symbol of geometrical feature, straightness, and this is the geometrical tolerance, specified tolerance, and this complete block is known as feature control frame. So, according to dimensional tolerance, lower limit will be 9.950 and upper limit will be 10.050. So, this is the dimensional tolerance zone, which is 0.100. But according to geometrical tolerance zone, will be like this, which is 0.02 distance apart to parallel lines. Let's see separately. Now this is dimensional tolerance, which is 0.100. So according to dimensional tolerance, if this surface is manufactured like this diagonally, it is acceptable. This is also acceptable. But geometrical tolerance is 0.02. So according to geometrical tolerance, it is not acceptable. Now observe the lines. These lines are more flat, means more straight than previous lines. You can see. So geometrical tolerance is controlling the geometric feature, means straightness. Now, in this dimensional tolerance zone, geometrical tolerance zone may shift anywhere from top to bottom. Wherever it is manufactured, from that position, it will control the geometrical feature. It will control geometrical feature like this. If it is manufactured in between this, then it must lie in this region only, or like this. So I hope you understand how geometrical tolerance is defining the dimensional tolerance. Next time we will see flatness, circularity, and cylindricity geometrical tolerances, and then we will go for dependent geometrical features.